All right, this is the Physics Chapter 5 final exam review. We'll be doing one of these each day in preparation for the final exam. Your file that you need to print off looks like this. It covers review questions from chapters 5 through 9. It's in the Files section of Microsoft Teams. The print is so small for this video that I went ahead and made an enlarged print for us to read off of for this video. So our first question says a 10-kilogram box of cat food is pulled across level ground by a hissing possum. If the angry varmint pulls with a force of 90 newtons, what is the acceleration experienced by the box? And we have a static coefficient of friction of 0.5 and a kinetic coefficient of friction of 0.3. All right, so let's draw out a free body diagram. Some teachers might just call it a force diagram. We know that the box is 10 kilograms. It is being pulled by a possum, which I will not draw, with a force of 90 newtons. We know that friction is involved because we are given the coefficient of friction. So friction is working against us. We know this is on a flat surface, so the normal force is just going to be the weight, which is mass times gravity. So that's 10 times 9.8. So that's going to be 98 newtons. All right, so we can get friction, our frictional force, because we know it's mu sub k, since it's moving, times the normal force. Mu sub k is 0.3. The normal force we just figured out is 98. And so we would have that as 29.4 newtons. Okay, we know that the summation of all the forces is equal to mass times acceleration. So that's going to be 90 newtons minus the force of friction, 29.4 newtons, is equal to the mass, 10 kilograms, times acceleration. All right, so this would be 60.6 newtons. That's 90 minus 29.4. Divide that by 10 kilograms. And you'd have 6.06 meters per second squared is equal to your acceleration. All right, so Chapter 5 problems are pretty straightforward. You don't want to miss any of those on the final exam. All right, pause the video if you need to, and I will erase. Number 2 says, what is the mass of a petrified hunk of Caleb Gillum if it takes 500 pounds of force to get it moving? All right, that's a former student of mine, my first year. Just an inside joke there. I probably should have changed that to just a petrified hunk of wood a long time ago, but I still don't do that. It means nothing to you. All right, 500 pounds of force to get it moving. We want to know what's the mass. All right, so let's just draw a mass. It takes 500 pounds to get it moving. We know that friction will oppose us. Okay, so just to get it moving, we know that the sum of all the forces is equal to mass times acceleration, but just to get it moving means there is no acceleration yet. Okay, just to get it broken loose. So the summation of all the forces is going to be equal to 0. that means that 500 pounds, minus 500 pounds to the right minus friction to the left is equal to 0. So 500 pounds has to be equal to the friction. Okay, we know that friction is equal to mu sub s in this case because it's static, because we're just trying to get it moving, times the normal force. All right, so we would have 500 pounds is equal to mu sub s, which is 0.4, times the normal force. So the normal force is equal to 500 pounds divided by 0.4. All right, so that's going to be 1,250 pounds. We know, since we're on a flat surface, that the normal force is just equal to the weight, which is equal to mass times gravity. All right, we want to know the mass. Okay, so we would have 1,250 pounds is equal to the mass, and gravity in this case would be 32 feet per second squared. So mass is equal to 1,250 pounds divided by 32 feet per second squared, and that is going to be 39.1. Do you remember the unit of mass for the English system? I'll give you a second. It is the slug. So 39.1 slugs. All right, so pause the video if you need to, and we'll move on to number 3. All right, number 3 says, Tyler T., also a student from my first year, stands on an elevator while deciphering screech vocal heavy metal music lyrics that no one else on God's green earth can understand. Tyler was very much into that kind of music. If Tyler weighs 490 newtons, what force is the elevator exerting on him to accelerate upwards at 2.2 meters per second squared? All right. So we have, we'll draw a picture of Tyler here. He's a very thin young man. Kind of had longish hair there. Wasn't very happy. Give him a little bit of a frown. All right, and we know that his weight is going down, and that is 490 newtons. We know that the normal force, or really just the force, but normal force, is what we're trying to get. All right, so we know that we're probably going to need to get Tyler's mass. And that's weight divided by gravity, because we're going to have F equals ma going on here. So when you're going to need to get the mass. So 490 newtons divided by 9.8. All right, and that is 50 kilograms. Okay, so we know that the sum of all the forces on this elevator is equal to mass times acceleration. So that would be the normal force minus the weight going down, 490, equals the mass, 50 kilograms, times acceleration, 2.2 meters per second squared. All right, so 50 times 2.2, and then add 490, and you will get the force that the elevator is putting on Tyler as 600 newtons. All right, so there you have it. Pause the video if you're still writing, and I will move on to number 4. Number 4 says, with what force must the great Cornholio push a 0.2 kilogram roll of toilet paper to keep it moving at a constant velocity? All right, this is a cartoon character from a cartoon called Beavis and Butthead, and it gives a static and kinetic coefficient of friction. All right, feel free to not watch the cartoon, but maybe you're curious. If so, you can watch it. Pretty crude. All right, so we've got a roll of toilet paper. It's in short supply these days. All right, roll of toilet paper. We have a force being exerted to push that toilet paper. And we know that friction is opposing us. And we know it needs to move at a constant velocity. So you would have the sum of all the forces is equal to mass times acceleration. But constant velocity means that is 0. So the sum of all the forces is equal to 0. So that means F minus F is equal to 0. So the big force is just going to be friction. We know that friction is equal to constant velocity is moving mu sub k times the normal force. The normal force on a flat surface is just equal to the weight, and that's going to be 0.2 kilograms times 9.8. All right, so that is going to be 1.96 newtons. So our force of friction, mu sub k, is 0.23. And then our normal force was 1.96 newtons. And so that's going to be 0.4508 newtons. So the force of friction is also equal to the force that you have to push the toilet paper with to get it to move at a constant velocity. All right, so pause if you need to. And let's finish this set of problems up with number 5. So number 5, we're going to repeat problem 4, assuming that the great Cornholio must push the TP with an acceleration of 5 meters per second squared in order to reach the almighty bunghole of Nicaragua before sunset. This has to do with the cartoon. It makes no sense if you don't watch the cartoon. Again, feel free not to watch it. So once again, we're going to have roll of toilet paper. All right, and we want to know what force has to be pushed or has to be utilized to get the acceleration to be 5 meters per second squared. All right, and we already know the mass is equal to 0.2 kilograms. The force of friction is just going to be mu sub k times the normal force. The normal force is equal to the weight, which in the last problem we figured out was 1.96 newtons. So 0.23 times 1.96 newtons. So that was the answer that we got last time, 0.4508 newtons. Okay, so if the sum of all the forces is equal to mass times acceleration, we would know that big F, which we're trying to figure out, minus little f is equal to mass times acceleration. So big F minus 0.4508, right, that's this right here, is equal to the mass 0.2 kilograms times acceleration, which is 5 meters per second squared. All right, so solving for F, so this is 0.2 times 5 would be 1 plus 0.4508, so it's 1.4508 newtons. So that does it for Chapter 5. Chapter 5's problems are much shorter than Chapter 6, so the Chapter 6 video tomorrow, of course, would be quite a bit longer, but that's okay. We'll worry about that then. And what you need to be doing now is, let me address this. In the files section, right, in the files section, you have this sheet, the second quarter test review text problem answers. So the problems that you need to be reworking to prepare for the final exam are all the practice problems and all the extra practice problems in chapters 5 through 9. So I made this sheet up for you so you don't have to go searching through your notebook to see what the answers are. So what you need to be doing today after you watch this video is just start working some of the practice problems and extra practice problems from chapter 5. All right, just get going on that. Maybe you work the practice problems now and save the extra practice problems for later in the week. However you want to do it. Okay, so that'll be it for this video, and I will talk to you next time.